Hey, seventh graders, it's Mrs. Wyland here. I am out today working with Mr. Michelson to grade all of your fantastic crime scene papers and projects that you created. So while I'm away, I wanted to tell you what you'll be working on with the sub. First of all, hopefully you came to class today with your best attempt at the seismic wave challenge, and perhaps some of you are at the point where you are able to explain this image here. If you want to take out your yellow sheets for the sub, that would be great to do right now, and hopefully you have all of your lines here on your earth just as I have up on mine. So if you're the sub, if you'd like to stop and pause while kids take out the yellow sheet, that would be great. Now that you have your yellow sheets out, why don't we think about whether or not you're able to answer the question that's up on the screen. If you could explain to someone at your table what all the lines represent and why exactly we did this activity last class. So again, if you'd like to pause and have a discussion, you are welcome to do so. What I'm going to do now is make sure we are all aware as to why we did this assignment last time. So I'm going to keep clicking through this presentation for you. So obviously, this is our Earth. I think most of us are good with that part. And while you worked on this assignment last time, you had different things to click on, different links. And so I'm going to also go through those with you right now. So one of the links you clicked on was about S waves. And I think many of you are going to think that S waves stand for seismic waves, but in fact, there are many different kinds of seismic waves. There are P waves and S waves. And actually, S wave stands for secondary because it's the second type of wave that comes out from an earthquake. S waves move up and down, and they can also move the earth side to side or the rock side to side. So you're going to have to know that later in our unit, and we'll keep reviewing how our S waves move. Last class, you started with this activity where you were asked to draw 9 different seismograph stations on your Earth. So I'm going to pop those up here now, and you were asked to number those. So here are our 9 stations. Then after that, you were asked to draw a line from station 1 to 3 and to measure its distance in centimeters. A lot of students got somewhere around 8.5 centimeters. And then beyond that, you were asked to calculate how many miles would it be from stations 1 to 3. You would have gotten 586 miles. And then you were asked if you could travel your electric car through or from stations 1 to 3. And some of you caught on that you actually can't drive a car through the earth and that in fact you would have to go around. So it's okay if you said yes, because 586 is less than the 600 miles that the battery would go for the electric car. And it's also wonderful if some of you said no, because you were already thinking about how you have to go around the surface of the earth, not through it. So beyond that, you were asked then to draw a little stick person at station 2, because that is where you were going to pretend to be located for the rest of the activity. You also had to watch a little video about epicenters, which is where an earthquake begins. That's what we call it. And you saw in the video that to determine the location of an epicenter, you needed 3 readings from 3 different seismograph machines to be able to figure out where an epicenter is located on the planet. You also were asked to watch a video, or at least click on a link, about the Richter scale. The Richter scale is a measuring system to determine how strong an earthquake is. It goes from numbers 1 to 10. And the most important thing to really remember about the Richter scale is that as you increase from 1 to 2 and 2 to 3, each earthquake is 10 times stronger, is 10 times more energy is being released than the previous earthquake number. So for example, if I have an earthquake at a 1, a 2 is 10 times stronger than a 1 earthquake. However, a 3 is 100 times stronger than a level 1 earthquake. And a 4 earthquake is 1,000 times stronger than a level 1. Some of you that have had some higher level math classes may know this as the earthquake is exponentially increasing in strength as we go up the Richter scale. Then on your piece of paper, you were asked to draw in quite a few lines, and we had a pretend earthquake that happened here at Station 6, and you drew 6 lines as seen on the screen. These lines represent seismic waves, and in particular, they represented secondary waves, the kinds of waves that can move up and down and from side to side. They move the rock of the earth in those directions. And then you were asked, well, why didn't stations 1 and 2 over here pick up on the wave? And as I walked around, I saw a variety of answers from students. Here are some examples of things I heard. I heard that perhaps stations 1 and 2 were too far away from station 6 because it's on the opposite side of the planet. Perhaps the earthquake was just not strong enough to send waves all the way across. Or perhaps there was human or equipment error of some kind with the seismograph machines at those stations. All are wonderful answers to have at this point in the activity. Then we pretended a second earthquake occurred over here at Station 8, and you were prompted to draw your secondary seismic waves, which you did. Then you were again prompted to think about why don't stations 3 and 4 receive the seismic waves. Much of your answers were the same as with the previous earthquake, which is perfectly acceptable again at this point to have. Then we had a third earthquake occur. You were asked to click on a website to learn more about how many earthquakes happen on our planet every day. Some of you may have said hundreds of earthquakes, which is perfectly acceptable. Some of you did some math and you may have calculated that on average about 35 earthquakes happen on average. The number of 35 is probably more accurate. Hundreds is a bit high, but either one I would accept just as we're learning about earthquakes. Okay, so then we had a third earthquake occur. Oops, excuse me, I'm going to head back there. And here are the seismic waves that you drew. And a fourth earthquake. And again, we had our seismic waves, but the opposite stations are not receiving any data. The seismic waves are not picking up that an earthquake occurred. At some point, you were prompted to watch a little video about P waves. P stands for primary, which means first. These are the types of waves that come out of an epicenter. They move very quickly. And that is why they are called primary waves, because they move across the Earth's surface first. They compress and expand the ground. So if you put your hands in front of you and clap and then release your hands and clap and release, that is really what a primary wave does to the rock. It will compress and expand. And primary waves can go through solids and liquids. Then we had a fifth and final earthquake occur, and you drew your seismic waves. So really your final yellow sheets are, it should look like this, what you see up on the screen, all of those lines. Okay, then you're prompted to watch a little video about tsunamis, and you are asked, what is a tsunami exactly? So a tsunami is a giant wave that is caused by an earthquake, or it could be caused by a landslide. If we have an earthquake happen here on the bottom of our ocean, the ground will move, which displaces and moves the water. Then the waves will continue and will pick up speed as it heads towards land. And as that occurs, the wave and the energy continues to increase. And tsunamis are very destructive. In fact, many of you probably heard that within the last 2 weeks, there was a large tsunami that hit Indonesia. So then finally you are asked, well, why were no seismic waves going through the center of the Earth? At this point, students had lots of different ideas. But I did hear some students, and the conclusion that I was hoping that you would make is that perhaps there is something here in the center blocking our seismic waves from going through. And that is the exact conclusion that scientists made when they looked at data just like you did in class last time. Scientists were curious as to why seismic waves, secondary waves, would not go through the middle. And scientists knew that seismic waves and in particular our secondary wave, does not travel through liquids. So they concluded that perhaps there was something liquid here in the center of our Earth. And after watching the video, hopefully that you saw that was linked to the assignment, you learned that our outer core is actually a liquid. It is liquid iron. And so we can now conclude that the reason why our seismic waves did not go through the center is because there is something blocking it. We have a liquid outer core. You were also asked to learn a little bit about the seismic wave shadow zone. And so if there was an earthquake over here on the planet, waves will be sent out in either direction, okay, kind of like this. But then there will be a portion of the Earth way over here, if you can follow the cursor, that does not receive any S waves, any secondary waves. P waves can go through because P waves can go through liquids, but S waves can't. So this is our S wave shadow zone. And by having the shadow zone, it actually tells us that there must be something liquid on the inside that is blocking those S waves from traveling through. So that is what the cause of our S wave is. All right, so here's what you're going to do today as you work. If you came to class with your yellow sheet completed, then I would like you to start on number 1 up here. If you did not come with the yellow sheet completed, I would like you to work on that first and get that finished, and then continue with number 1 up here on the screen. What number 1 is you're going to head to Schoology. And on Schoology, let me get there, you are going to, in the assignments folder, find something that looks like this. So it's called the Seismic Wave Challenge Reflection. This will be graded, and this will tell me how much you really understand of the assignment that we did on the yellow sheet. So there's a variety of questions. You're going to type in your answers. There's 3 slides. On this slide, you are asked to either describe in words what the inside of our Earth looks like. You could also insert, so you can go up here and insert a picture and create a picture of the Earth and label the layers. And then finally here, you are asked to explain what the S-wave shadow zone is and why it occurs. When you're finished, please submit it on Schoology for a grade. After that, then you will find up on the front table a bunch of packets, and you're going to want to put your name on the packet and write down your class period. And then if you could please number the packet. I forgot to have this done before I made copies, but if you could number the packet, you should start with the first page right when you open it is page 1, and the very last page is going to be page 19. Once you're done numbering, pages 1 and 2 have learning targets and vocabulary. So I'd like you to look at those and preview those and actually score yourself with your current knowledge. A 0 means you've never heard of the term at all. It's totally new to you. A 1 would be like, I've heard of the word or the idea, the concept before, but I don't really know what it means. A 2 is I know a whole lot about it. And a 3 is I know it so well I could teach it. And you can kind of see a snapshot over here of what I mean, how you would write your number next to the learning targets and next to all the vocabulary words. So I actually want you to do pages 1 and 2 in the packet. Once you're finished with that, please complete packet pages 3 and 4. So to do page 3, you're going to head to the back corner of the room where you see the book cart, and there's some big red textbooks. The thick red ones are the geology textbooks. And on the top of page 3 in the packet, it tells you what pages to read. And then to accomplish page 4, you're going to want to head to back to Schoology. And if you click on today's date of the 15th, you're going to see down there this Google Slides for page 4, and you're going to use the vocabulary on here. Oops, nope, that's not right. Let me go back. You're going to use the vocabulary in order to complete page 4. I will fix this for you so that you actually get the correct vocabulary. So please have pages 3 and 4 completed for when I see you all on Wednesday. And happy learning about the inside of the Earth. See you soon.